Hey, welcome to this lesson, which is bug fixing and blueprint code cleanup. In this lesson, we are going to remove any unused code for our game, and we are going to organize our code by using comment sections. And then we are going to solve a couple of bugs that I have found while developing this game. So let's start this lesson by removing any unnecessary code we have created so far. I'm going to come over to my level blueprint. And let's just take a look at all the code we have created so far. So we have our begin overlap event for the trigger box, which triggers the win message for when our ball escapes out the maze. So we want everything we've added here. If we move further up, we have the event tick, updating the rotation of the static mesh maze with our mouse input. So this is good, we certainly want this. And further up, we have some input action events for rotating the floor actor. Well, we are using the mouse for our input now, and we are not even using the floor actor. So we can remove all of these nodes here. And let's actually come back into our level and delete the floor actor if you haven't done so already. Let's come back to our level blueprint. And let's move up to where we have our begin play node. We have a few delays and print strings here from an earlier lesson. If you want, you can use a print string here on the begin play for a welcome message to the game. So we would just need a single print string for this. We can get rid of all the other nodes, and we can just hook this up just to the begin play here. And a simple welcome message could be something like, "Welcome to my maze, how fast can you escape?" And we can change the color if we want, and change the duration here. I'm going to change mine to 2 seconds. And we can test this out by coming back to the level and hitting play. And now we have a simple message that pops up when we play the game. But it's a bit quick, so I'm going to come back to my level blueprint. And I'm just going to change the duration of my welcome message from 2 to 4 seconds. Okay, so what else can we do here? Well, we can organize our code further by selecting nodes. And when we have nodes selected, we can press the C key to add a comment section. So we can comment these nodes as a welcome message. We can come down to the event tick where we rotate the maze floor actor with our mouse input, and we can comment these as maze mouse input. And we can comment our box trigger code as win level event. With comment sections selected, we can see on the details panel that we can change the comment's color and font size. And we can also select and move every single node in the comment section just by clicking and dragging and moving the comment section. We can select multiple comment sections and we can click and drag them to move them up. And now we have all our code organized nicely into one place. So your challenge right now is to organize your code into comment sections and have a go at changing the color of the comment sections as well. So pause the video here and give that a go. And when you're ready, come back to the lesson. Okay, so I've coloured my welcome message comment section as blue, my event tick as red, and my win level event as green. So this is great, this is a lot more organised for us. Let's head over back to our level, and let's take a look at some potential bugs that might happen when we play the game. I'm just going to hit play, and I'm going to fast forward to the end of my maze. We can see that if we move the maze around while the ball is escaping, we get more than one win message. So let's break this down. When the ball exits the trigger box, we get our first win message. So this is fine, this is what we want. However, if we move the maze, the ball can end up back inside the trigger box and then fall out of it again, causing additional messages. So really our solution to this is to make sure that we only fire this event once. And Blueprints allows us to do this very easily. Let's come back to our level blueprint. And let's look towards where we have our win level event, which is really just the end overlap event of the trigger box. So we only want this event to fire once. So how can we do this? Well, we can use a flow control node. If we drag out from the execution pin of the end overlap and then come down to utilities and then the flow control category, we can find a bunch of nodes here that affect how we execute our code. And look, we have a do once. When we hover over this, it says output fires only on the first time this node is hit. So this is great. We can use this in our code, and we can see when we add it, it adds it nicely into our comment section here. Let's come back into our level and let's test this out just by hitting play. So now we only get the single win message. So the do once node has helped us here. This is what we can use to limit our blueprint code to only fire once. So let's take a look at another bug with our game. When we hit play and rotate the maze really quickly, we can see that the collision of the ball gives up and it just falls through the maze. So let's take a look at what's happening here and what we can do to fix it. So this issue is a result of us adding rotation. Looking at the mouse X inputs, if we don't move the mouse, we have an input value of 0, and this results in no change for the roll rotation for the maze. If we move the mouse, we might end up with an input of 0.8 for the mouse X, and this means that we will be teleporting and rotating the roll of the maze by 0.8 units every frame. And this is okay because it's gradually increasing its rotation every frame, and the ball can catch up, it has a chance to update its location and still collide. So really, we are teleporting the maze to a new rotation every frame, and there's an issue here. If the roll is at 0 and then suddenly teleports to a new rotation that is vastly different than before, the ball can end up inside or below the mesh, and this is what causes the ball to fall through. So we need to limit how much rotation we can apply at once to avoid this issue. We can also mark the ball to be more accurate with its collision detection. This is a setting known as continuous collision detection, and this actually helps, but it's not a complete solution. It's turned off by default, but it's okay for us to use because we only have one physics actor in our game, so it's not going to be heavy or cause a problem if we use it. But the real solution here is to clamp the mouse input values. So this is how we can avoid the ball falling through the maze. So let's take a look at enabling continuous collision detection for the ball. This could potentially cause performance issues if we enable this on hundreds of physics actors, but we just have the one, so it's perfectly okay for us to use. So to do this, we can just select the ball, and on the details panel, we can scroll all the way down till we find the collision section. And we can expand this little white arrow that says show advanced when we hover over this, and we can find some more settings here, and look, it says use CCD, which is continuous collision detection, and we can just go ahead and check this. And now we also want to take a look at clamping our mouse input values. So to do this, we want to head back to our level blueprint, and where we have our maze mouse inputs code, let's find our mouse X return value. With this, we can clamp it by simply dragging it out and releasing the float return value. And we can type and search for clamp. And we want to use the clamp float here. And now with the clamp return value, we want to make sure that it gets added to the current roll of the maze. And now all that's left is just to set how much we want to clamp the mouse input to, and this might vary for different mazes. But for me, clamping the mouse between -1 and +1 works well, but just remember you can change this to suit your maze. And now we want to repeat this for the pitch controls of the maze. So with the mouse Y and also with the multiply where we invert the value, we can drag out the return value here and search for the clamp function again. We just want to make sure that we add this to the current pitch of the maze, and that we clamp this between, well, for me it's going to be -1 and +1. Okay, so this looks good. We now have it set up so our mouse input values are clamped. So let's come back to our level and let's just hit play to test this out. Okay, so this looks good. I no longer have the issue where the ball is falling through the bottom of the maze. So, as with any game during development, unexpected issues might pop up and you might find some yourself. So we might want to provide a way that a player can restart the level if they want to. So now I have a real challenge to test your blueprint skills. I want you to add an input action event, also known as a key event, and I want you to use this event to restart the level. And then make sure that you add a comment section for this blueprint code. So pause here and attempt to have a go at this, and then when you're ready, resume the lesson and I will walk you through the process. Okay, so to do this, I'm going to come next to my welcome message section. I'm going to right click and then come down to the inputs category. And I'm going to look for a keyboard event. And we're going to use, let's say, the R key here And we can use this input action event to restart the level. Well, how do we restart the level? Well, we just need to call the open level function. So we can drag out from pressed and we can type in open level, and we can just restart the level by providing the level name here, which is level 1 for me. And then we can select all of this code. We can hit C to add a comment section, and then we can name this restart level. And then I'm going to hit compile and save. And now we can come back to our level and we can hit play. When we press R, we now have a way that the player can restart the level if they wish to. Great, so you might find more issues in your game, and if you do, don't worry, feel free to share them in our community so we can take a look, and you might even get some help from some students that have similar issues. For the next lesson, we're going to take a look at packaging our game so we can play it in a standalone mode without the Unreal Editor. So when you're ready, I'll see you in the next lesson. Hello and well done for making it this far. This lesson is packaging your game. In this lesson, we're going to take a look at how we can run the game without the Unreal Engine 4 editor present. We're going to take a look at how we can set the default levels that open when we launch the editor or when we launch our packaged game. We're going to learn how we can reduce the size of the game by only packaging the content we are using, and we will take a look at the difference between development and production builds. Okay, so I'm assuming you're happy with your maze now, and remember our maze is converted down to a single static mesh, so if you want to make any changes to the design of your maze, you'll have to start over with the BSP geometry. But we can still change materials without having to do this, because we made sure at the BSP level that we had applied different materials to the walls and to the floor. So you can use the starter content materials just by dragging and dropping them onto your walls and floor to make sure you're happy with the final look of your maze. So we have our playable game in the editor, but now we want to run it like a regular game without the editor. So in order for us to do this, we need to package our game. But there's a few things we want to take a look at before we go through the packaging process. So to do this, we want to come to the project settings, and we can find this by coming up to edit and then project settings. So this has brought us to the description section of the project settings, and there's some basic things we can do here, just like changing the default icon for our project that we see in the Epic Games launcher, and we can also change the default name from UE4 game to something else. For me, it's just going to be Marble Run. And there's other details you can fill out here about your project and yourself, but for now let's move on by coming to the maps and mode section of the project settings. So what can we do here? Well, here we can set the default maps for the project. We can set the editor startup map and also the game default map. And we can see the maps assigned to them both here. And if you remember back when we first opened our project, it opened the minimal default map. And this is why it opened it, because it's set to open it by default here. And we can change the level that is opened by default for the editor by dropping down and selecting our chosen map here. So we can just select level 1. But we can also set a different map that opens by default when we launch our packaged game. So we don't want our players to be in the minimal default level. So I'm just going to go ahead and change this to my level, which is level 1. Okay, so this is looking good. We know that when we launch our game, we will be in the correct level. So now let's move on to the packaging section. So we only have one goal here. By default, if we were to package our game, it would package every level that exists in our project and every piece of content that is used in those levels. But really, we only want to use one level, and we are only using 2 static mesh actors and a couple of materials in our level. So we only want to package what we use, which will limit the amount of unnecessary content being packaged. So underneath where we have the packaging section, we're not going to worry about all these options here. Instead, we want to show some more advanced options, and we can do this by clicking on this little white arrow, which allows us to see some more advanced settings. So we are looking for the checkbox that is named Cook Only Maps. So this is what we need to use in order for us to only package particular levels. We can go ahead and check this, but we now need to go down and look towards where we have list of maps to include in a packaged build. So we can add levels that we want packaged by hitting the plus icon, and then we have to browse to where our level exists by hitting this browse icon. It will browse to the content directory of our project, so we can just come to the folder where we stored our level, which is maps for me, and then the map file, which is level 1 for me. Okay, so this is good. We are now ready to package our project. So we can close the project settings, and now we can take a look at how we can package the game. To do this, we want to come up to File, and if we look down, we have the Project section, and here we can package the project. There's different platforms we can package for, but we have designed this game for desktop, and I'm using Windows, so I can only package for Windows, and because of this, I am unable to package for Mac. I would have to open my project on a Mac in order to package for it. So for Windows, I can package for 32-bit or 64-bit machines, but I'm not going to package just yet because there's something else we need to be aware of. If we look further down, we can choose a build configuration. We have a choice of development or shipping. So this is actually going to affect our game. Let's back up a step. What do I mean by this? Well, let's come to our level blueprint and take a look. Looking at a print string function, we can see that it's marked for development only. So when we hover over it, it says this node will only be executed in the editor and in development builds in a packaged game. It will be disabled in a shipping build. So if we were to package a shipping build, it's not going to print our string messages to the screen. So we want to make sure that we use the development configuration. Another difference between development and shipping configuration is that the shipping has the console command disabled, which we haven't yet taken a look at, but I just wanted to point that out for you. So let's actually go ahead and package our game now. We want to make sure we are using the development configuration, and we can proceed with packaging for the platform we are running. So I'm running on a Windows 64-bit machine, so I can select this here. It now asks us to browse on our machine to where we want our game to be packaged to. I have got a Marble Run folder on my machine, so I can choose this here, and as soon as we hit select folder, it's going to start the packaging process. It doesn't take too long to package the project, but I'm just going to fast forward for now. So now my game is packaged. If we browse to where we packaged the game on our machine, we will find a folder named Windows No Editor. So it's packaged it for Windows with no editor needed to run it. We can rename this folder just by selecting it and hitting F2, and I'm just going to name mine Marble Run. When we come inside this folder, it shows us some content files and folders, but the main important one here is that we have a marblerun.exe. When we double click this, we launch our game, and we are now playing the game without the dependency on the Unreal Engine 4 editor, so this is completely independent now. So we can make our ball escape, and when we do, we get our win message, and then after 5 seconds, the level restarts. And we can manually restart the level by pressing the R key. But what happens if we want to quit the game? If we hit escape, it's not closing the game for us. That's because that's a control of the editor and not the game itself. We have to set this up manually, so I'm going to have to hit Alt F4 to close out of my game. So let's fix this up so we can press escape to quit the game. Let's come back to Unreal and let's open up the level blueprint. And in here, we want to add some code that will allow us to quit the game by hitting escape. So your challenge right now is to add an escape input action event to the level blueprint, and then try and find and use the quit game function. And then with this, add a comment section. So pause the video here and have a good go at it, then resume the lesson and I will walk you through the process. So to do this, we can right click in the graph and we can come down to where we have input and we look for the keyboard events, and here we can find the escape key. So we have our escape input action event, but how can we call the quit game function? Well, we can either come to the game category or we can just simply type and search for quit game and we can get the function this way. Okay, and finally we just want to add a comment section for this line of code. So let's just hit compile and save to save the level, and let's close the level blueprint. And now we are ready to package the game again, but we need to delete the previous packaged build. So we can come back to the folder and just delete the whole Marble Run folder we have here. Okay, so once this is done, we can come back to the editor and then File and then Package Project and then Windows 64-bit it will be for me. And then we can just hit Select Folder and it will start packaging again. So I'm just going to fast forward through this process again. And now with the package complete, we can come back to the folder where we packaged the game. We can rename it from Windows No Editor to a custom name for our game. And we can open the folder to find our exe, and we can use this to launch our game. Okay, so we can play, we can press R to restart, but now we can hit escape to quit the game. Okay, awesome. So now you know how we can take an Unreal Engine 4 project and compile it down to an independent, playable, packaged build.